like to have a very simple example. You know that this is a spring mass system. That means we are not considering damping. Then if suddenly a constant force is applied, a sudden application of constant force means it's a dynamic force. That means just suddenly you are putting some weight on a beam. Okay, so it will keep on vibrating. But if you gradually put the weight, that means very gently, if you just first touch the weight on the beam and then gradually you lose your holding so that the weight is gradually transferred to the beam, then it is static loading. Okay, we are not very much clear about what is static loading and what is dynamic loading. But if we just take the weight and just suddenly leave it on the beam, so it's a dynamic loading. But suddenly the beam receives that load. So it is a sudden, if the sudden constant loading is given, then also the system will undergo a vibration. And if the load is gradually applied, then the resistance will gradually build up, and so we know that there will be a linear curve, force versus displacement, and then the area under that curve will give us the energy stored. And then uh, but for this particular case, and in that case, the displacement will be, if the stiffness of the beam is k, then the displacement will be f0 by k. But if in this case, just let us try to see what will be the displacement. You see f0 sine omega t minus tau. So if we integrate it, we will get modulus of cos omega t minus tau t to 0. And then if we substitute, if we carry out the integration, definite integration, this is a definite integral, then we will get f0 over k into 1 minus cos omega t. So this f0 by k, we can say the static displacement. That means if we gradually apply the load, just the load is not, if it's a 100 kg load, it's gradually I am losing my grip, and that's why first a small amount of load, then a slightly larger amount of load, then a further larger amount of load. So that way gradually the load is being transferred. Then the displacement what will be created, that may be denoted by yst, which is equal to f0 by k. And if we apply this force dynamically, that means suddenly, then the displacement function will be f0 by k into 1 minus cos omega t. So that means yst into 1 minus cos omega t. So what can be maximum, and then it will be 2 yst. That means, and that's why generally we call that the dynamic effect is twice that of the static effect, because if we have to design a system for this kind of a load, then we have to design it so that it can take 2 times of the displacement what it would have taken if the load would have been applied statically. So this you can see yt equal to f0 by k 1 minus cos omega t, and it becomes 2 yst y max. And if you just plot the curve, then it will then this vibration will continue, and then the maximum value, see, this is the static displacement, and but because of the vibration, the maximum value will be up to 2 times yst, and so the and the system will keep on vibrating because there is no damping in the system. So can you now say if there is a rectangular load? Okay, rectangular load, that means say it is the force F0 is suddenly applied but only during a limited time duration TD. That means here we are considering that it is continuing. The load is continuing, continuously applied. Once suddenly the load is applied F, then it is sitting over there. But here, what is happening? The load is, there will be a difference if the load is suddenly applied, and then it sits over the system for a fixed time duration TD, and then the load is removed. Then how you can take care of this? A similar situation but slightly different. Can you just try to think of it? That means, see that up to the time instant TD, you can apply the response, you can calculate the response by using Duhamel integral. And then when the load is taken back, then the system will undergo free vibration. That means at time equal to TD, you try to calculate what is the displacement and what is the velocity. Once you know that, so that will be the initial displacement and initial velocity for the free vibration, because the load is being withdrawn, for the free vibration which will be performed during the next part of the time. Now we'll end it up here. I'll request you to try this problem, and then next day we'll discuss it. But uh, I'll request you to attempt this problem so that when next day we'll discuss this problem, you'll be able to check whether you are correct or not. And once you can, if you are able to do it yourself, then you should gain the confidence, and it will give you also a proof that you are understanding the thing. Okay, so that's all for today.